everyone. Welcome to the 2020 TensorFlow Developer Summit livestream. I'm Kacholia, VP of Engineering for TensorFlow. Thanks for tuning in to our 4th annual Developer Summit and our first ever virtual event. With the recent developments of the coronavirus, we're wishing all of you good health, safety, and well-being. While we can't meet in person, we're hoping the Dev Summit is more accessible than ever to all of you. We have a lot of great talks along with exciting announcements, so let's get started. When we first open-sourced TensorFlow, our goal was to give everyone a platform to build AI to solve real-world problems. I'd like to share an example of one of those people. Erwin is a radiologist in the Philippines and no stranger to bone fracture images like the ones that you see here. He's a self-proclaimed AI enthusiast and wanted to learn how AI could be applied to radiology, but was discouraged because he didn't have a computer science background. But then he discovered TensorFlow.js, which allowed him to build this machine learning application that could classify bone fracture images. Now, he hopes to inspire his fellow radiologists to actively participate in building AI to ultimately help their patients. And Erwin's not alone. TensorFlow has been downloaded millions of times with new stories like Erwin's popping up every day. And it's a testament to your hard work and contributions to making TensorFlow what it is today. So on behalf of the team, I want to say a big thank you to everyone in our community. Taking a look back, 2019 was an incredible year for TensorFlow. We certainly accomplished a lot together. We kicked off the year with our Dev Summit, launched several new libraries and online educational courses, hosted our first Google Summer of Code, went to 11 different cities for the TensorFlow Roadshow, and hosted the first TensorFlow World last fall. 2019 was also a very special year for TensorFlow because we launched version 2.0. It was an important milestone for the platform because we looked at TensorFlow end-to-end and asked ourselves, how can we make it easy to use? Some of the changes were simplifying the API, settling on Keras and eager execution, and enabling production to more devices. The community really took the changes to heart, and we've been amazed by what the community has built. Here are some great examples from winners of our 2.0 Dev Post Challenge, like Disaster Watch, a crisis mapping platform that aggregates data and predicts physical constraints caused by a natural disaster, or Deep Pavlov, an NLP library for dialogue systems. And like always, you told us what you liked about the latest version, but more importantly, what you wanted to see improved. Your feedback has been loud and clear. You told us that building models is easier, but that performance can be improved. You also are excited about the changes, but migrating your 1.x system to 2.0 is hard. We heard you, and that's why we're excited to share the latest version, TensorFlow 2.2. We're building off of the momentum from 2.0 last year. You've told us speed and performance is important. That's why we've established a new baseline so we can measure performance in a more structured way. For people who have had trouble migrating to 2, we're making the rest of the ecosystem compatible so your favorite libraries and models work with 2.x. Finally, we're committed to 2.x core library, so we won't be making any major changes. But the latest version is only part of what we'd like to talk about today. Today, we want to spend the time talking about the TensorFlow ecosystem. You've told us that a big reason why you love TensorFlow is the ecosystem. It's made up of libraries and extensions to help you accomplish your end-to-end ML goals, whether it's to do cutting-edge research or apply ML in the real world. There's a tool for everyone. If you're a researcher, the ecosystem gives you control and flexibility for experimentation. For applied ML engineers or data scientists, you get tools that help your models have real-world impact. Finally, there are libraries in the ecosystem that can help create better AI experiences for your users, no matter where they are. All of this is underscored by what all of you, the community, bring to the ecosystem, and our common goal of building AI responsibly. We'll touch upon all of these areas today. Let's start first with talking about the TensorFlow ecosystem for research. TensorFlow is being used to push the state-of-the-art of machine learning in many different subfields. For example, natural language processing is an area where we've seen TensorFlow really help push the limits in model architecture. The T5 model on the left uses the latest in transfer learning to convert every language problem into a text-to-text format. The model has over 11 billion parameters and was trained off of the colossal clean crawled corpus dataset. Meanwhile, Mina, the conversational model on the right, has over 2.6 billion parameters and is flexible enough to respond sensibly to conversational context. Both of these models were built using TensorFlow. And these are just a couple examples of what TensorFlow is being used for in research. There are hundreds of papers and posters that were presented at NeurIPS last year that use TensorFlow. We're really impressed with the research produced with TensorFlow every day, at Google and outside of it. And we're humbled that you trust TensorFlow with your experiments, so thank you. But we're always looking for ways to make your experience better. I want to highlight a few features in the ecosystem that will help you in your experiments. First, we've gotten a lot of positive feedback from researchers on TensorBoard.dev, a tool we launched last year that lets you upload and share your experiment results by URL. The URL allows for quickly visualizing hyperparameter sweeps. At NeurIPS, we were happy to see papers starting to cite TensorBoard.dev URLs so that other researchers could share experiment results. Second, we're excited to introduce a new performance profiler toolset in TensorBoard that provides consistent monitoring of model performance. We're hoping researchers will love the toolset because it gives you a clear view of how your model is performing, including in-depth debugging guidance. You'll get to hear more about TensorBoard.dev and the new profiler from Gal and Schumann's talks later today. Researchers have also told us that the changes in 2.x make it easy for them to implement new ideas. Changes like eager execution in the core. It supports NumPy arrays directly, just like all the packages in the PyData ecosystem you know and love. The tf.data pipelines we rolled out are all reusable. Make sure you don't miss Rohan's tf.data talk today for the latest updates. And TensorFlow datasets are ready right out of the box. Many of the datasets you'll find were added by our Google Summer of Code students, so I want to thank all of them for contributing. This is a great example of how the TF ecosystem is powered by the community. Finally, I want to round out the TensorFlow ecosystem for research by highlighting some of the add-ons and extensions that researchers love. Libraries like TF Probability and TF Agents work with the latest version. And experimental libraries like JAX from Google Research are composable with TensorFlow, like using TensorFlow data pipelines to input data into JAX. But TensorFlow has never just been about pushing the state of the art in deep learning. A model is only as good as the impact it has in the real world. This is one of TensorFlow's core strengths. It has helped AI scale to billions of users. We've seen incredible ML applications being built with TensorFlow. We're really humbled by all the companies, big and small, who trust TensorFlow with their ML workloads. Going from an idea to having your AI create real-world impact can be hard, but our users rely on TensorFlow to help them accomplish this. That's because the TensorFlow ecosystem is built to fit your needs. It makes having to go from training to deployment less of a hassle because you have the libraries and resources all in one platform. There's no switching costs involved. I want to highlight a few new things that will help you get to production faster. First, you've told us that you love working with Keras and TensorFlow because it's easy to build and train custom models. So we're committed to keeping tf.keras the default high-level API. But if you're not looking to build models from scratch, TensorFlow Hub hosts all the ready-to-use pre-trained models in the ecosystem. There are more than 1,000 models available in TF Hub with documentation, code snippets, demos, and interactive collabs, all ready to be used. When you're ready to put your model into production, you can build production-ready ML pipelines in TensorFlow Extended to make sure your ML engineering just works, from data validation to ML metadata tracking. And today, I'm very excited to announce that using TensorFlow in production is getting even easier with an exciting launch: Google Cloud AI Platform Pipelines. We've partnered with Google Cloud to make it easy to build end-to-end production pipelines using Kubeflow and TensorFlow Extended, hosted by Google Cloud. Cloud AI Platform Pipelines are available today in your Google Cloud console. And if you're running TensorFlow on Google Cloud, TensorFlow Enterprise, which we announced last year at TF World, gives you the long-term support and the enterprise scale that you need. Finally, you can train and deploy your models and pipelines on custom hardware specifically designed for AI workloads, cloud TPUs. In the latest version, TensorFlow is now optimized for cloud TPUs using Keras. This means the same API you started with now helps you scale to petaflops of TPU compute. All of these libraries are within the TensorFlow ecosystem, are 2.2 compatible, and help you scale so your ML application can reach your users. But for AI to have that kind of impact, it needs to be where your users are, which means getting your models on device. Now, we all know this requires working in some constraints, like low latency, working with poor network connectivity, all while trying to preserve privacy. You can do all of this by using tools within the TensorFlow ecosystem. Like TensorFlow Lite, which can help make your models run as fast as possible, whether it's on CPUs, GPUs, DSPs, or other accelerators. Here's an example of how we've optimized performance for MobileNet V1 from May last year to today. It's a big reduction in latency and something you get right out of the box with TF Lite. We're also adding Android Studio integration so you can deploy models easily. Just simply drag and drop into Android Studio and automatically generate the Java classes for the TF Lite model with just a few clicks. When network connectivity is a problem and you need these power-intensive models to work while still offline, you can convert them to run better on device using TensorFlow Lite. In the latest version, we rebuilt the TF Lite converter from the ground up to provide support for more models, more intuitive error messages when conversions fail, and support for control flow operations. The browser has become an exciting place for interactive ML, and TensorFlow.js is allowing JavaScript and web developers to build some incredible applications. There's some exciting new models that are now supported, like Face Mesh and Mobile BERT. Hugging Face introduced a new NPM package for tf.js, which allows you to do question answering directly in node.js. Finally, the new WebAssembly backend is available for improved CPU performance. The next few years will see an explosion of platforms and devices for machine learning, and the industry needs a way to keep up. MLIR is a solution to this rapidly changing landscape. It's compiler infrastructure for TF and other frameworks. And it's backed by 95% of the world's hardware accelerator manufacturers, and it's helping to move the industry forward. We see how important infrastructure like MLIR is to the future of ML, which is why we're investing in the future of TensorFlow's own infrastructure. The new TensorFlow runtime is something you won't be exposed to as a developer or researcher, but it will be working under the covers to give you the best performance possible across a wide variety of domain-specific hardware. We're planning on integrating the new runtime later this year, but you'll hear more from Mingxing later today. So to recap everything you've seen so far, whether you're pushing the state-of-the-art in research, applying ML to real-world problems, or looking to deploy AI wherever your users are, there's a tool for you in the TensorFlow ecosystem. Now, I'd like to invite Manasi on stage to talk about how the ecosystem is helping empower responsible AI. Thank you.
Thanks, Megan. Hi, everyone. My name is Manasi Joshi, and I'm an engineering director on TensorFlow team. As Megan mentioned and you saw, TensorFlow ecosystem is composed of a number of useful libraries and tools that are useful for a diverse set of use cases, whether they are coming from ML researchers or practitioners alike. However, the field of ML and AI is raising the question whether we are building systems in the most inclusive and secure way. I'm here to tell you how TensorFlow ecosystem empowers its users to build systems responsibly, and moreover, what type of tools and resources are available to our users to accomplish those goals. Before we deep dive into the details of what TensorFlow has to offer its users, let's take a step back and define what we mean by responsible AI. As we know that machine learning has tremendous power for solving lots of challenging real-world problems. However, we have to do this responsibly. Now, to us, in TensorFlow, the way we define responsible AI is based on a 5-pillar strategy. Number 1, general recommended practices for AI. This is all about reliability, all the way from making sure that your model is not overfitting to your training data. It is more generalized than that. Making sure you're aware of limitations of your training data when it comes to different feature distribution skews, for example. Ensuring that the model outputs are robust when the training data gets perturbed. Ensuring you're not using only a single metric across all your models to determine its quality, because different metrics matter to different contexts. How your model is used for promotion, demotion, filtering, ranking, so on and so forth, right? The second principle, fairness. Fairness is a fairly evolving thing in AI. For us, we define it as not to create or reinforce unwanted bias. Fairness can be extremely subjective, can be context sensitive, and it is a socio-technical challenge. Third, interpretability. Interpretability is all about understanding the mechanics behind models' prediction, ensuring that you understand what features really matter to the final output, which features were important, which features were not. Fourth, privacy. For us, this is all about taking into account sensitivity of your training data and features. And fifth is security. In the context of ML, security really means that you understand vulnerabilities in your system and the threat models that are associated. Now, for a typical user of TensorFlow, this is how the overall developer workflow looks like. You start by defining a specific goal and objective for why you want to build the system. Then you go about gathering relevant data for training your model. As we understand, data is gold for machine learning model training. And so you have to prepare the data well. You have to transform it. You have to cleanse it sometimes. And then once your data is ready, you go about training your model. Once the model is built, it's converged, you then go about deploying the model in production systems that want to make use of ML. Deployment phase is not a one-time task. You have to continuously keep iterating in an ML workflow and improving the quality of the model. Now, along this developer workflow, there are many, many different moments at which you as a modeler needs to be asking all of these questions. Questions like, who is the audience for my machine learning model? Who are the stakeholders, and what are the individual objectives for the stakeholders? Going on to the data side of it, is my data really representing real-world biases or distribution skews? And do I understand those limitations? Am I allowed to use certain features in a privacy-preserving way, or they are just simply not available due to constraints? Then on to the training side of it. Do I understand implications of the data on model outputs or not? Am I doing deployments very blindly, or am I being a little bit mindful about deploying only reliable and inclusive models? And finally, when we talk about iterative workflow, do I understand complex feedback loops that could be present in my modeling workflow? Now, along all of these questions, I'm happy to tell you that TensorFlow ecosystem has few set of tools which could be helpful to answer some of them. I'm not going to go through everything here, but to just give you a few examples, starting with fairness indicators. It's a very effective way by which you can evaluate your model's performance across many different subgroups in a confidence interval-powered way, such that you can evaluate simple but effective fairness metrics for your models. We have what-if tool that gives you the notion of interpreting the model's output based on the features and changing those features to see the changes in the model's output. It has very compelling textual as well as visual information associated with your data. And then finally, TensorFlow Federated. It's a TensorFlow 2.x compatible library that helps you train your models with data that's available on device. Kat and Miguel have a talk later today that dives deep into fairness and privacy pillars of the responsible AI strategy. Be sure not to miss it. We are excited to work on this important part of TensorFlow ecosystem with all of you, the TensorFlow community. And now, to talk more about the community, I would like to turn it over to Kemal. Thank you.
Thank you, Manasi. Hi, everyone. My name is Kemal, and I'm the product director for TensorFlow. So you've heard a lot from Megan and Manasi about our latest innovations. Now I'm going to talk about the most important part of what we're building, and that's the community. And I want to begin by thanking all of you. Your feedback, your contributions, what you build, this is what makes all of this possible. We have an incredible global community. We love hearing from you, and we really appreciate everyone that came out to a roadshow of our TensorFlow World last year. And going into 2020, I want to take some time to highlight more opportunities to get involved in the community and new resources to help you all succeed. Let's start with ways you can get involved locally. One great way to connect is to join a TensorFlow user group. These grassroots communities started organically, and we now have 73 of them globally. We launched the first 2 in Latin America after the roadshow in São Paulo, and now we expanded our presence in Europe. The Korea group is the biggest with 46,000 members, and China has user groups in 16 cities. I'm sure this map can have a lot more dots, so if you want to start a user group, please reach out and we'll help you get started. Another way to get involved are the special interest groups, or SIGs. SIGs exist to help you build areas of TensorFlow that you care the most about. We will have 12 SIGs, with SIGs Graphics being our latest addition starting at the end of the month. Most SIGs are led by members of the open source community, such as our fantastic Google developer experts. We love our GDs. We now have 148 of them, and I want to take a moment to recognize all of them. They give tech talks, organize workshops, and doc sprints, and I want to give a special shout out to Hason, pictured above, who organizes doc sprint in Seoul. They reviewed several PRs and wrote hundreds of comments in 5 hours. Again, GDs are amazing, so please let us know if you're interested in becoming one. Okay, so TensorFlow user groups, SIGs, and GDs are great ways to get involved, but we all love a little competition, and we all love Kaggle. As Kaggle now supports 2.x, we've had over 1,000 teams enrolled in our last competition. I want to give a special shout out to our 2.0 prize winner, Deep Thought. And speaking of competition, we saw great projects in our last DevPost challenge, including Psychopathology Assistant, an intelligent assistant that tracks patients' responses during face-to-face and remote sessions. And everyone danced faster. And everybody danced now video generation library using HTPU and TensorFlow 2.0. Thank you to everyone who participated. And today, we have a new challenge. So Manasi spoke earlier about how TensorFlow can help empower all users to build AI systems responsibly. So we want to challenge you to create something great with TensorFlow 2.2 and something that has the AI principles at heart. We can't wait to see what you build. So another area that we're investing in a lot is education, starting with supporting our younger community members. For the first time, we participated in Google Code-In, and it was a success. We were very impressed by the students, and we want to thank all the awesome mentors who made this possible. We hope someday to see the students at our Summer of Code program. I love Summer of Code. It's an awesome opportunity for students to work with TensorFlow engineers. We saw amazing projects. In fact, one of the students worked on data visualization for Swift, which is still being used today by our team. So I'm happy to announce we're doing it again this summer, and we're excited to see what new projects students will work on. Programs like this are key to the growth of the developer community, so please visit the Summer of Code website to learn more and apply. We also want to help produce great educational content, starting with our machine learning crash course, a great resource for beginners. So today we launched an updated version of the course. Our NGDU team completely revamped the programming exercises using Keras 2.0 and made them much simpler in the process. Go check it out on this link. And we want to provide resources at every stage of learning. At the university level, we want to empower educators and support them as they design, develop, and teach machine learning courses. Last year, we supported Georgia Tech, the University of Hong Kong, Pace University, and many others. And this year, we have a commitment to fund schools from underrepresented communities in AI, historically Black and Latinx colleges and universities. So if you're a faculty and you want to teach ML, please reach out. And we also want to help people self-study. That's why we partner with deeplearning.ai to give people access to great educational material. To date, over 200,000 people have enrolled in our courses. The data and deployment course is a great specialization course that covers TensorFlow.js, TensorFlow Lite, TensorFlow dataset, and more advanced scenarios. This is a great option for people who are really looking to build their ML coding skills. And you can audit it for free. And there's more. Imperial College London just released a Getting Started with TensorFlow course on Coursera. This course was created in part by the TensorFlow funding I mentioned earlier, and we're super happy to see this. So you're taking all these courses, you're becoming better at ML, but how do you show your expertise to the world? This is why I'm excited to announce the launch of the TensorFlow Certificate Program, an assessment created by the TensorFlow team, covering topics such as text classification, using NLP to build spam filters, computer vision, using CNN to do image recognition, sequences and prediction. By passing this foundational certification, you'll be able to share your expertise with the world and display your certificate badge on LinkedIn, GitHub, or the TensorFlow Certificate Network. And to widen access to people of diverse backgrounds and experiences, we're excited to offer a limited number of stipends for covering the certification costs. You can find out more at tensorflow.org/certificate. So, a lot of things to do. And I want to thank you again for making the TensorFlow community so awesome. As you've seen, the TensorFlow ecosystem is having incredible impact in the world today. And what it really comes down to is how AI is helping make people's lives better. That's really what inspires us as a team to build all these amazing tools. So I'd like to end by sharing one final story.
Médecins Sans Frontières is providing care in 70 countries. Each time we go in a new country, in a war zone, we discover more and more patients infected with multi-drug resistant bacteria. They're arriving with the wrong antibiotics given to them. Antibiotic resistance is everywhere. If we don't act today, we'll have 10 million deaths per year by 2050. Once you identify that there is a bacteria, you do multiple tests to know which type of bacteria it is, and then you test the sensitivity of several antibiotics in order to identify the most effective one. There is an additional step that is the interpretation of those results. In the majority of the countries where we work, there is a lack of microbiologists and human resources to do this interpretation step.
Anwar, he is 10-year-old, and his injury was a bullet. It exploded inside his leg. He has very resistant type of infection. We are the last hope for Anwar.
I thought AI might be one of the solutions to this problem.
We developed an application to help lab technicians to interpret the results of diagnosis tests only using their mobile phones. We're using TensorFlow, computer vision, and machine learning to detect interactions happening between the bacteria and antibiotics based on an uploaded image of the petri dish. Our goal is not to replace the lab technicians. The app is really meant to support them in doing their diagnosis test, whilst always keeping a human in the loop. We managed to train a model within a matter of days using Keras and 15,000 anonymized pictures of diagnosis tests. The API was super expressive, and it was surprisingly really quick and easy to achieve. We are deploying the app using TensorFlow Lite, so it can be used offline on any range of mobile devices in all of our clinics.
Today we have a prototype. We've got a responsibility to make the diagnostic test available, easy, affordable, all over the world. I'm excited because for me this application can be a game changer that's going to help millions and millions of people.
For anyone. There is one antibiotic suitable for this infection. I think this app, it will solve many problems everywhere in the world.
That's just amazing and incredibly inspiring. When I see something like this, it makes me very proud to be building TensorFlow. So go build amazing things, and we'll be there to help. And with that, I'll pass it on to Paige to kick off our day. Thank you.